Hello everyone, welcome to my YouTube channel. I'm Rohit, and today I'm going to um, discuss this very important question: what is an electron? Now, one might say, what exactly am I talking about? Because people have a illusion that they know what is an electron, and um, so today I'm going to just attempt to literally mm, derive how an electron looks or might look um, as per DJR. So I'm going to just derive how the electron is. Now this is going to be a slightly longer type of video. So I want you all to be patient. This is of course a PPT and almost till the 17th slide, I think. Um, the DJR part will not start. So, but most of the things which I am going to discuss today are extremely relevant to why I am saying how the electron looks, or how I'm going to derive the electron with the help of assumptions of dynamic general relativity. So, for those who are new, I am Rohit, and I am the author of this book, Decoding Gravity, Time, and Causality, in which I have basically described what is called as dynamic general relativity, which is a new theory of quantum gravity and a theory of everything. So I keep on saying this, that there are basically there's one time related assumption, there's one space related assumption of dynamic general relativity, and there are three process related assumptions. So there are just five assumptions, and with these five assumptions, gravity, that is Newtonian gravity as well as Einsteinian gravity, just pops out of the theory. Even things like momentum, kinetic energy, everything pops out. Even the electron, or how it looks, or how it would look, it can very well be derived just by pure logic. So I am just assuming those um, five assumptions of the theory, and with those five assumptions, we can just derive the entire electron. How exactly we are going to do that? We are going to just see how we can do it. But beware that whatever I'm going to do is not typical methodology which routine physicists uh, employ. So you have to be a bit ready for a thought process which is slightly different. So we first come to some basics basically. So what is an electron? This is a very interesting question, and the lesser you know about physics, the more you would say that yes, we know what is an electron. But more and more you know about physics, you start getting an idea that we just don't know anything at all about the electron, what it is and how it is and how it looks and what it does. So the only thing which we are slightly sure about is what it does. But how it does what it does, we don't know still. Anyhow, so before the advent of quantum mechanics, there was classical mechanics. So in that, the quantum was very simple actually, described by J.J. Thomson, and um, we know that it was a subatomic particle. It was negatively charged. It was basically in that cathode ray tube. It got deflected towards positive electrode. Uh, it was known that if two electrons come together, they will repel each other, and the electron basically attracts a proton as well as a positron. So these things are classical. So it is much easier to imagine the electron in that manner. You know, there will be a small sphere-like particle, which is subatomic particle, and it repels itself and it attracts the positron and the proton. So the classical electromagnetism also says that, you know, the electron has a charge, so it is a negatively charged particle. So it has lines of forces which start from the positive charge and end in the negative charge. And so there will be lines of forces all around it, and that's basically the electric field. So the electron has a property to modify the electric field around itself. So okay, here till here we are a bit clear. There's no confusion yet. Okay, and a bit of a confusion starts, but okay, these lines of forces are there, and if the positive and the negative they are there, then the lines of forces match, and then that's why they attract each other. But if the two positives or two negatives are there, the lines of forces will not match, so they will repel each other. Whatever was the teaching in classical electromagnetism, which made sense, okay, but it was still not very convincing, because this what exactly is this electric field and what are these lines of forces, we did not know. But with the advent of quantum mechanics, everything changed. So we know that this is basically only a part of the truth. So classical mechanics, you know, employing classical mechanics, they thought that, you know, the atom is made up of the majority of the mass of the atom is concentrated in the center, and the center is basically per gram. It is basically positively charged, and the negative charge. So the atom is neutral. So all the positive charge is in the center, and all the negative charge is in form of the electron. So the electron is bonded to the positively charged proton. So this was relatively simple to imagine, and most of the undergraduate textbooks will also teach this, but this is wrong. They know it, that the electron cannot stay in orbit like that. So if it does, it will keep losing energy and it will keep falling down. But it doesn't happen in the real atom. So the real atom is much more stable than what this particular model tells it to be, which essentially means that, you know, this classical mechanics or classical uh, description of electron is wrong. So then came the quantum description. So they realized that, yeah, electron is not exactly a classical particle. It's not like a ball, or it's not like a tennis ball. So it's not a classical particle. It's a quantum particle. So it basically behaves the rules of quantum mechanics. So it is a miniature magnet. So the charges, whatever is the property of the electron which gives it its charge, the charges are actually moving within the electron. Even if the electron is stationary, there is some movement of the charges which is taking place within it, which makes it a small miniature magnet, and then that property is called as the spin of the electron. And electron is actually a spin half particle. So anyhow, the approximate the probable diameter of the electron is 10 to the power minus 18, which is a very small diameter. The diameter of the proton is actually 10 to the power minus 15 meters, which is a femtometer. So electron is even smaller than that. So femtometer itself is extremely small, but the electron is even smaller. So it is almost, for all practical purposes, we cannot measure it, and it is like a point particle for us. So its diameter is 10 to the power minus 18, and it's a quantum particle. So quantum particle, what exactly does it mean? So quantum mechanics, it behaves all like a quantum particle. So it is like a wave and particle both at the same time, and also it is you know, in superposition of multiple states. So it can actually be in a superposition of multiple states. Like It can be in a superposition of upspin and downspin. It can get entangled with its pair positron, and it can send information faster than speed of light to it. So these are all the properties which it can see. So it can pass through multiple slits at the same time. It can its location and momentum obey the uncertainty principle. So you cannot know the momentum as well as the position or the location both together. And also its location and its further course or path is determined by what is called as a wave function. So which basically gives only the probability of where the so all this is known actually. So there is no doubt about all this, but little is known about what exactly is this wave function and how exactly the electron does what it does. So it does behave like a particle and a wave, but exactly how it does we don't know. So how exactly the superposition of the electron is the thing we don't know. How the entanglement occurs we don't know. How the so all these things are made the electron. Initially we thought that we know the electron, but now with all this, we have not known the electron now. So it has its knowledge has become even less. Its picture has become much more blur in front of our eyes. So initially it was like a sphere which is rotating, but now it's not a sphere. It's a sphere as well as a wave, particle as well as a wave, and then it. So you can understand that with the advent of quantum mechanics, everything has changed about electron. The electron is not what it used to be before. So now the electron can be actually smeared into atomic orbitals. Now quantum field theory has made it even worse. Quantum field theory says that there's an electron field which is all around, and the electron is just a positive excitation of that field, and negative excitation of the same field is the positron, which is the antiparticle of the electron, which makes a lot of sense as far as the mathematics is concerned, but as far as the theory is concerned or understanding is concerned, it makes a very little sense. So it's not very based on logic, but we know that it's true. So we know that it. So what exactly would dynamic general relativity say? So there is one more less talked about model of an electron, which is called as a spinor. So this is not exactly an electron, but any charged particle. But yes, this can be an electron. So it has these bands, and the central sphere is rotating, and these bands are fixed to the periphery. So they cannot rotate, but they can change shape. So the sphere can keep rotating, and it will come back to its original position after two rotations. So that's what is a spin half particle. Now this is a pretty good description of electron, but we know that it cannot be right, because if it is an electron, then it is more like a particle rather than a wave. And the electron, what exactly is the electron? The strings are the electron, or the central spherical region is the electron. If it is the central spherical region, then the electron has a definite position as well as definite momentum, which is against the uncertainty principle. So although this is spinor is a very interesting, and I want you to keep this image in mind, because it's a very interesting image, and I was not even aware that this is one of the description of the electron, but this is this I want you to memorize this figure so that we can compare it with the later emerging description of the electron as described by dynamic general relativity. So here we have a very vague idea of what the electron is. It is a wave particle. At the same time, it can be at multiple places at the same time. It's a quantum particle. It can suddenly appear. Electron and a positron pair can appear from suddenly from anywhere and can be transported or teleported from one place to another, and it can get entangled, and it can stay in superposition of up and down spins. So it's like a weird particle and particle wave dual. So we don't know what exactly is electron in short. So there are quite a few questions which the physics today's physics, both quantum as well as classical physics, they just brush under the carpet. Like yeah, we know that electrons repel each other, but what exactly is the mechanism with which they repel each other? Why the electron is attracted by the proton? And the typical answer is exchange of photons. So one electron approaches the other electron and it sends a photon to the other electron, and in that photon carries the momentum with it. So the electron exchange photons, and that's how they repel each other. So this is a typical Feynman diagram in which this is the electron, first electron, and this is the second electron. So this electron comes from here and approaches the second electron, which is going in this direction, and the photon is exchanged, and this electron is repelled, and this electron goes here. So this is a typical Feynman's diagram. Physicists say that you should not overanalyze it, because it is not exactly accurate, and it is just for understanding's sake. But yes, this diagram is actually more of an equation rather than a diagram, and so you should not overanalyze it. But still, this photon, what exactly it is, we don't know yet. So what exactly is the process taking place inside? We don't know. Now there are other questions, like this is a hydrogen atom. So we know that protons and electrons will keep getting attracted towards each other. So this is a electron, and this is a proton. Proton is positively charged. So what we know is that this electron should keep falling down, but as soon as it reaches the atomic orbital, it stops. So the innermost allowable atomic orbital, it stops. So its further descent down is prohibited. We know from Newton that if there is a force which is directed in this direction, there has to be some force which is directed in the opposite direction to prevent its fall down. So if this second force, which is directed opposite to the attractive force, is not present, then the electron will keep falling down. But we know that doesn't happen. So we know that the first atomic orbital, the electron stops. So how exactly it is? So the classical mechanics cannot explain this, but quantum mechanics can explain this. Quantum mechanics explains it by the electron wave. So the electron is not only a particle. This particular ball-like picture which we have in mind is actually wrong as far as quantum mechanics is concerned. Quantum mechanics says that the electron is not like a ball. It's not like a particle, but it's a particle and a wave dual. And that's why the electron is not only here, but it's like a here. It's like a wave, and this electron wave, it keeps coming closer and closer to it until the first electron, atomic orbital, where the wavelength of the wave is such that that the circumference of this is the integer multiple of it. So one crest and one trough will form the circumference. So that's what was described by um, de Broglie. De Broglie's wave, electron wave. So anyhow, so the quantum mechanics suggests that, but what exactly is this electron wave? How it goes? How it goes around it? Why not? Why it doesn't go straight like that? These are all questions which, you know, an inquiring mind, a logical mind will keep asking, and there's no answer to it. Why is this electron wave not moving in a straight line? Why it is moving in a curved line? So here we have to keep one thing in mind, basically, that light is also a wave actually, and we know that this kind of a circular behavior, circular movement of the wave would, indicate that the geodesic over here is also curved, just like the geodesic around this around the sun is curved, and that curved geodesic the earth just follows. So here also the geodesic is curved. In the same manner, if there is a black hole just outside the event horizon of the black hole, there will be a curved geodesic because of the black hole. So this curved geodesic is the reason why, if the light is trapped around, it can keep moving all around in circle. So this circular movement of the electron wave could be a clue to us that there is a curved geodesic around the mass of the proton. Because of the mass of the proton has much more mass than the positron. So the positron, if this is a positron, then it will keep falling down. So there won't be excessive mass. So the curved geodesic won't be there. So the electron wave would not curve around. But here, because the proton has much more mass, there is much more curved geodesic. So that's why the electron wave can go around it and return back, and it can probably provide the necessary repulsion. So this is basically a clue for us, but we still don't know what exactly is this electron wave. Okay, we still have no clue why exactly the electron doesn't keep falling down. So these are unanswered questions. Why electron stops moving towards the proton beyond the innermost allowable atomic orbital? There is no answer to this. There's a very vague answer to this, that there's an electron wave, it goes around and it provides, but we don't know what an electron wave is and how it goes and why it goes, why there is a curved geodesic around the proton. All these are answers which, they are brushed under the carpet. So what is the outward wave, outward force, which overcomes the inward directed force? So there's an inward directed force from electron to the proton. So this will not go away by itself. How should it go away? It should not go away. But if it doesn't go away, then it should keep falling. Why it is not? What is the counter force which stops it at the first and innermost orbit? We don't know. So this is not okay. So here we end what we know actually. So this is what we know for now. So now I am just going to try and derive how dynamic general relativity, um, the assumptions of it. Just if we consider these assumptions, the electron can be derived or it pops out. You don't need to work very hard for deriving the electron. Okay, so but before that we have to carry on the tradition of Einstein of having a thought experiment. So let's think of a thought experiment. Let's imagine that there is a spaceship, and this spaceship is about 10 to the power minus 18 meters. So it's basically the size of the electron. So very tiny, very small, but it's a spaceship. So this is an electron spaceship. Basically, we think that the electron is a spaceship. and it's spherical, and Miss X is sitting. So here I don't want to put a male inside. So this could be anyone, Alexandria or anyone. It could be Miss Lakshmi, or it could be Miss Tina, or it could be Alexandria or Elizabeth, whatever you want to call her. So she is sitting inside the spaceship. She has a photon gun basically. And what is her task? Her task is basically there is to find out if there is an electron coming approaching, and you have to blast the photon. Now we know that if this is an electron and this is also an electron, and if there is an Elizabeth sitting here, then there should be an Elizabeth sitting here also. So if this is a spaceship like electron, this should also be a spaceship like electron. So because the two are identical in a sense that they are fermions, so they cannot be distinguished from one another. They are absolutely same. So no two electrons can be distinguished just by themselves. So in that case, there will be a Lakshmi or Elizabeth sitting here, and she will also have a photon gun. But we know that this is basically a quantum particle, so we don't know what is the location of it and the momentum of it, and it is moving in with the speed of almost 99% of the speed of light, and it is basically wave and a particle at the same time, and it is at multiple locations at the same time. So and this is 10 to the power minus 18, and it is extremely far away. Maybe for this 10 to the power minus 18 size, this is extremely far away, maybe a few meters far. So for this girl to hit its target, it's very, very difficult. And so our typical Feynman's diagram of one particular photon going from this to the other electron, it looks like stupid actually. So there cannot be one single photon going from one electron to the other electron, because it's the electron of course is not, there's no conscious person sitting there and watching the other electron and aiming for it. So there's no conscious person. Of course, this experiment, thought experiment is it shows the foolishness of the Feynman diagrams, that one photon going from the electron to the other electron is not unlikely to be true. Multiple photons. So what exactly would be the truth? Is that the spaceship will have multiple photons, and the multiple photons will go in all the directions, and they will basically be fired irrespective of whether a proton is approaching or another electron is approaching or not. And these photons will interact depending on what it is. So if the same photon might interact with a proton and attract it, or the same photon might repel another electron. So that way it is easier to understand that the spaceship, this is a much more easier to comprehend model. There's a spaceship and there's a conscious person sitting there, and he is just she just keeps on clicking the button, and she keeps on firing the photons in all directions, irrespective of whether an electron is approaching. And there is another similar conscious person sitting in the other spaceship who is also doing the same thing, hitting the button every one particular small fraction of time, and keeping on throwing the photons all around. And that is that these photons are the cause of the change in the electrical field, which is the reason for the charge. So anyhow, so we have basically shown that photons here are small ball like things, but we don't know really what exactly a photon looks like. Classically as well as quantum wise, we have no idea how it looks like. What is the geometry of it exactly? We know that it is a packet of energy, but what exactly is energy itself we don't know. So it's like energy is a abstract entity which does work, but what exactly is energy we don't know. Now another very interesting question is that yes, this photon has a momentum. Now think about it, that if two electrons are moving towards each other, they will exchange photons and they will repel each other. What about if one electron and one proton is approaching each other? What will happen is, well, the same thing, that the electron will pass a photon to the proton and then they will attract each other. So this is an attractive photon. So probably you have to understand that there are two types of photons. One is a repulsive photon and another one is attractive photon. So this repulsive photon, if it has a positive momentum, then the attractive photon should have a negative momentum, of course. So is there a negative momentum? Has anybody described it? Maybe, but it's not a typical teaching. So when we draw Feynman's diagram, we draw only one type of photon. So there are multiple probable types of photons. So what is the size of the photon? What is the shape of the photon? Is it a wave or is it a particle? Nobody knows. Okay. How does a photon look? We don't know. How many photons are emitted per unit time? So this Lakshmi or this Elizabeth or whatever she is, she has to click a button. So after how much time interval she will keep clicking the button. So one photon is going, the other photon, then the third photon, then the fourth photon. What is the photons per unit time which it is sending? So is it multiple photons or a single photon? How many photons? We don't know. So these are genuine questions which a person with logic would ask. What exactly is this photon made up of? How it is? Whether it is cylindrical, whether it is spherical, or whether it is elliptical or oblong or wave-like or particle-like. What exactly is the shape of the photon? We don't know. We don't know. Believe me, nobody. These are the questions which are brushed aside. So we don't know yet what exactly it looks like. So no theory is actually capable of deriving this. Nobody can derive this. So anyhow, so we are basically trying to derive how a photon looks with the help of dynamic general relativity. So let's imagine two electrons. So these two electrons are under influence of each other, and they are basically repelling each other. So this one electron gets repelled, and this. So let's say that let's consider this corridor or space in between these two electrons. Let's imagine that there are 10 to the power 100 Planck compartments in between the first electron and the second electron, 10 to the power 100. So as the time progresses, the first Planck time, the second Planck time, third Planck time, with the first Planck time, the 10 to the power 100 becomes 10 to the power 150. Then it becomes 10 to the power 200. Then it becomes 10 to the power 300. So the amount of space which is being the number of Planck compartments which are there in this particular corridor is increasing. So what exactly is happening is that the number of Planck compartments in them is increasing. So it figures that there is active expansion of space which is happening in between the two electrons, essentially, which means that the process of creation is predominant and the process of destruction is less predominant in these two. So what is the size of this corridor? Is it so the diameter of the photon, the proton, the new electron is basically 10 to the power minus 18. So should the diameter of this also be 10 to the power minus 18, or it should be more, or it should be less? It can be less also. It can be anything. So we don't know yet, but it can be very small also. So maybe we can imagine this corridor as a very thin line from going from here to here. And what is the shape of this corridor? We don't know. It could be straight like that, cylindrical, or it could be like that, or it could be like that, or it could be from here to here like that. So we don't know. We don't know yet. But yes, Dynamic general relativity would suggest that there is a corridor where active expansion of space is happening in between the two electrons. So what about the protons and the electrons? So in this particular corridor, what will happen is that there will be attraction, which means that what? That there is basically active spatial contraction. So there will be more destruction than creation, which means what? That the overall quantum foam from here to here would have a excess of destruction as compared to creation. Now we know in dynamic general relativity, active spatial expansion is negative energy and active spatial contraction is positive energy. So this is a negative energy photon and this is a positive energy photon. So the description of a positive energy and a negative energy photon in DGR is that it is basically having active spatial expansion and active spatial contraction. So we come to the assumptions of the DGR. Dynamic general relativity says that the whole space-time is made up of small Planck compartments which are stuck together, and there is something called as a Planck vacuum in between. So if you try to pull them apart, then the Planck vacuum appears, and they will keep pulled, keep getting stuck, or they keep getting pulled. So that's called as a Planck vacuum. So there is a Planck vacuum in between. So if one particular Planck compartment moves from one place to another, so they are basically free to move. So if they move, then there will be a Planck vacuum created. So the other person, the other Planck compartment also has to move. The third has to move, then the fourth has to. Like that, they will keep on moving. So there is it's like moving blocks type of puzzle is there, no? So like that, the small grains of space-time are movable. Now you can see two positive energy particles over here in this particular aspect. So here there is destruction happening. So how much destruction is happening? You can imagine that one compartment, Planck compartment volume, Planck volume is being destroyed in one Planck time. So here, one Planck time, every Planck time, one void appears. So these will get immediately entangled, and they will get pulled inside. So they will also get destruction in them, and then the outer part will get. So basically, a time resetting wave will start all around it, and it will pull the surrounding Planck compartments towards itself. So the next Planck compartments will get entangled, and then third, and then the fourth, and then the fifth. Like that, there'll be all around it. There'll be a time resetting wave which starts. So there'll be a time resetting wave which starts from here. There'll be time resetting wave which starts from here. So both of them will have a time resetting wave going all around it. But in the next Planck time arrives, there will be again another volume loss. And again, there will be a start of a time resetting wave, and Planck compartments keep moving inwards. So this is what is basically dynamic general relativity to positive energy particles. So what happens if they are not positive energy, but they are negative energy particles? So what happens is that there is a creation instead of destruction. So there is one here. If there is one Planck compartment being created, so these four Planck compartments will be pushed away. So if they are pushed away, all the surrounding Planck compartments will also get pushed away. Then again the same thing. Basically, what is happening is here the Planck compartments are being pushed outwards, so that there will be active creation there all around. So active expansion of space will be there, which essentially means that there will be a time contraction rather than time dilation. So time contraction type of EPCs are formed. That is point eddy Planck compartment aggregates are formed, or time contraction waves start. So there is a time resetting wave which starts even around a negative energy particle, like time dilation wave which starts around a positive energy particle. Now, so this kind of a wave is created. So these are Planck compartment aggregates which form. They get entangled and then they will be pulled inside. Then the outer part will get entangled and that will be pulled inside. Like that, the grains of sand or the grains of space will keep moving, and because of the active spatial contraction, there will be local time dilation over here. Okay, so this kind of waves will start developing. So you can understand that if it's a positive energy particle, there will be much more destruction than one time compartment. So there can be 10 to the power 10 Planck compartment being destroyed in a single Planck time. So huge amount of void being created in the center. So this causes a huge time receding wave to start. Very fast, these time receding waves start forming and they move outwards very fast. So they will travel very quickly within a single Planck time, several thousand Planck compartments. It can travel beyond. So it's traveling faster than the speed of light. Anyhow, so each of these eddy Planck compartment aggregates, or each of these time receding waves will have a time dilation. So the Earth also has a time dilation because of the destruction taking place in each of its cores. So you can see this particular positive energy particle is there, and there is a very similar field being created by the Earth. So I'm sorry about the numbers which you cannot see, but basically this is the hypothetical time dilation which we can see over here. Now, to understand this in detail, you will have to read the book. But basically, the thing which is saying is that if there is a time dilation which is caused because of the active contraction of space, because of the gravity of the Earth over here, and the time dilation of so this is hypothetical time dilation of this much, and there is a hypothetical time dilation of this much because of this particular positive energy particle. So then the two will get added up. So the two will get added up. That's why there will be more contraction here and less contraction here, less contraction here. So here there will be much less addition. There will be much less addition. So here there will be much less contraction than this. So there will be a difference in spatial contraction here as well as here. So this will contract much faster. This will contract much slower. That's why the particle will keep traveling in this direction till it reaches the Earth. So that's how the gravity is described. Anyhow, that's not what we are going to discuss today. But what we are going to discuss is what if there are two positive energy particles, what happens? So this is again a positive energy particle with a hypothetical. Now this again you will have to read the book to understand what exactly it is. But hypothetical time dilation of 7. So there are maybe you can say that 7 Planck compartments are being destroyed in a single Planck time in this particular thing. So 7 is the hypothetical time dilation. So here it will it should ideally not be linear like this actually, but this is basically hypothetical time dilation we are talking about. So there will be slightly less time dilation here, then slightly less here, then slightly less here, then slightly less. So we are just to understand, we are just trying to figure out what is going to happen. So if there is a 7 time dilation here, there will be a slightly less time dilation here. There will be slightly less here, then slightly less here, then slightly less here. In that same manner, if there is a 7 here, then 6, 5, 4, 3, 2, 1. So what exactly happens is that the time dilation because of this and the time dilation caused by this will both add up. So here there is 1 and here there is 6. So there will be 7 here, there will be 7 here, there will be 7. So basically these two positive energy particles will have a extremely high time dilation over here, because their time dilation and here is his time dilation. Both of them will get added up in the region exactly in between the two. So it's literally like a string which is of space-time, which is pulling the two particles together until the two particles come together. So these are what positive energy particles, which have active destruction going on in them. So there will be an active destruction even here, 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 here. So the space-time will keep contracting in between the two, and they will keep pulling towards each other. That's why the positive energy particles form aggregates. So if there are some, there is a third particle here, so that will also get pulled towards this and this, and all the three will come together, and they will form a aggregated particle. So of three particles. So like that, multiple particles can aggregate together. Now, what exactly happens if there is a negative energy particle? So if there are two negative energy particles, what happens? That they will have a So if there is they have a negative time dilation, or there will be a time contraction, which can be denoted as -7. So if the what exactly will happen is the same thing actually. So instead of 1, you write -1 over here. 7, you write -7. So here there will be all -7, -7, -7. Here all -7, -6, -5, -4, -3, -2. These are all hypothetical time dilations, because the time dilation will obviously not be linear like this. What is mentioned, but this is hypothetical time dilation. Just for understanding sake, we have understood. So here this is a negative energy particle with -7. So if this is a -7, this will also be -7. This will also be -7. Here there is active spatial expansion going on. So here also there will be active spatial expansion all throughout, which means that the two negative energy particles will repel each other. So they will not attract each other. They cannot form aggregates. So they will repel each other and they will keep separate. They will never meet. Now we don't know whether a negative energy particle actually exists. So this is all what dynamic general relativity would say, that if there is a negative energy particle, then they will repel each other. This is what DJR will say. Okay, this is what DJR predicts. Okay, so what happens if there is a one positive energy particle and one negative energy particle? Then what happens is that the hypothetical time dilation here will be really a mixture actually. So you can see over here that this is a positive energy particle with +7, that is time dilation of 7. So here there will be time dilation of 6, time dilation of 5, time dilation of 4, 3, 2, 1. So here there is -7, -6, -5, -4, -3, like that. So essentially what is happening is that here there will be positive and here there will be negative. So essentially what is happening is here there will be active spatial contraction. So this will pull the whole thing towards itself, but this will keep pushing away. This will keep pulling and this will keep pushing. This will keep pulling, this will keep pushing. So this particular particle will keep moving in this direction, and this particular particle will keep moving following this particular negative energy particle. So negative energy particle will keep moving in this direction and positive energy particle will keep following it. So this is actually exactly what Hermann Bondi described for, not for energy particles but mass particles. So what he suggested was that if positive mass particles are there, they will attract each other, but negative mass particles will repel each other, and a positive mass particle and a negative mass particle will have a typical accelerated motion, perpetual motion of Bondi, what it's called as. So the positive energy particle will keep running away and the negative energy particle will keep following it. So this is actually the opposite. The positive energy particle will keep attracting this -1, and this negative energy particle will keep moving away from it. So this is the perpetual energy motion, which was already described by Bondi, which is actually being this perpetual motion and positive mass and negative mass is basically popping out of the dynamic general relativity. So a positive energy so the only thing is that here Herman Bondi imagined that there is a -1 kg weight, but that is not possible as far as DGR is concerned, because minus for a single electron weight also huge amounts of positive energy particles have to coalesce and form aggregates, but the negative energy particles cannot form aggregates, so they cannot coalesce into negative energy mass. So negative mass particles cannot exist, but negative energy particles can exist, but they can exist only separately. They cannot clump together and form aggregates, especially now. Maybe in the early part of the universe, maybe they might have existed, but not now. So we don't know yet. But negative mass particle is not possible. But positive mass particle, because positive energy aggregates together, it is possible. So this is what is Herman Bondi. Okay. So what exactly will happen if there is a pair and they will approach each other? So this is a very interesting image actually. So if a positive energy particle and a negative energy particle form a pair, okay, so this positive energy particle will keep attracting the negative energy particle, but this negative energy particle will keep going away from it. So it is basically forming a pair, and it will keep moving. It will keep perpetually moving. It will not stay in one place. But this positive energy particle will attract this other positive energy particle. So essentially, what will happen is these will attract, but these will repel. These will repel. So this will form a pair like this. So positive energy particles will come close, and the negative energy particles will remain separate, and they will remain away because they are repelling the other partner. So other partner's partner. So this has a partner here. This has a partner here. Both will come together, but these cannot attract this. So this will keep repelling each other. So they will keep repelling each other. Now, if there are multiple positive energy particles which come together, then what will happen is multiple negative energy particles will keep remaining bonded, but they will remain separate and they will move away. So they will keep repelling each other, but they will keep getting attracted towards this. They'll keep getting attracted towards this, but they will keep repelling each other. They will form what is called as a mesh or a so they will basically line up all around, and they will form so this is what is the basic emerging description of the electron, which is also what is called as the matter antimatter model of the electron. So here there is a central core which is actually almost like a black hole, and in this black hole there is huge amount of positive energy, which is basically huge amount of destruction happening. So there will be a lot of positive energy particles clumped together, and they will keep destroying blank compartments. So they will form very fast, very rapidly moving inwards time receding waves. So there will be time receding wave forming all around. So multiple waves will form every Planck time. So Planck time is itself 10 raised to minus 43 seconds, which is extremely small fraction of the time. So every Planck time forward progression of the clock, there will be multiple time receding waves, which are basically active spatially contracting spherical waves. So there will be one sphere which forms, and this sphere will keep losing its volume, and will keep going inside, and will keep forming, keep moving inside. It will keep reducing in radius and also in surface area. So there will be one particular zone over here where the Planck compartments will form a EPCA or eddy Planck compartment aggregate, and they will cause active spatial contraction. As soon as uh, they move inwards, the outer part will form an eddy Planck compartment aggregate, which will come down. But you can understand that here these are negative energy particles, and so they will form um, a lattice-like structure all around the positive energy core. But they cannot come close to each other, so they will keep repelling each other. But they will have, if you can see that the place, so there will be one sphere over here of Planck compartments which are aggregated together, which will keep moving inwards. So there will be Planck vacuum created all around, but which cannot be fulfilled because these are negative energy particles. So they will keep increasing. Here a huge amount of creation is happening per Planck time. So if creation is happening, they will push all the surrounding Planck compartments. So here there will be positive energy wave, the negative energy wave, or rather time contraction wave. So here there will be time dilation wave. Here there will be time contraction wave. So if there is time contraction wave here, the space is actually expanding. So if the space is expanding, the surface area of it is expanding. So it will not be able to it will not be able to supply the Planck compartments over here. So what happens is that Planck compartments are being pulled from the small region over here. So essentially what is happening is that the waves which travel from here to here will basically have a hindrance from passing in this direction. So they will pass through this direction. So they will create another wave here and another wave here, and they will interfere. The wave coming from here and the wave coming from here will interfere, and basically they will form zones over here. So one zone will be positive energy zone, one zone will be negative energy zone, and there will be one zone which will be the zone in between the positive energy and the negative energy zone. So in one of the zones where negative energy is predominant, there will be active spatial expansion. So there will be spatial expansion here. There will be active spatial contraction here, and here there will be no relative spatial expansion or contraction. So zone C will be um, zero energy. So this will be positive and negative energy or active expansion. This will be active contraction, and here will be no expansion contraction. So that's how the electron would look. So the electron, um, uh, contrary to our understanding, is actually made up of not only positive energy but also negative energy. And the negative energy, the manifestation of negative energy, is in the form of the electron charge. So the charge of the electron is itself the manifestation of the presence of high amount of positive energy, negative energy, both in the electron. So the positive energy is the reason why there will be thin corridors of active spatial expansion around the electron, and there will be thin corridors of active spatial contraction also all around the electron. So what exactly will happen to this lattice structure? It cannot remain stable in one particular order. So it will keep rotating in a very rapid manner because active spatial expansion is happening in this direction. So but the space expansion cannot go in this direction. So there can be no compensation of the active spatial expansion here in this direction, here in this direction, or here in this direction. So it has to go all over here. So in one Planck time, there will be 10 to the power minus 1 second, there will be 10 to the power 43. There is more than 1 meter of extra space is being formed over here in each of them. So that's why this whole sphere is going to rotate very rapidly. But you have to understand that these are quantum particles, and these are ENEA particles. So they are very, very tiny, and they are having active spatial expansion. So they can travel much faster than the speed of light. And this is not exactly a rotation because of inertia, but this is rotation because of active energy, which is negative energy, which is there in them. So the inertia, because the rotation because of inertia, it doesn't apply to this particular sphere, because this is active spatial. This is basically the energy within the positive energy particle or the negative energy particle, which is basically pushing the lattice structure outwards. It's not because of inertia, it is because of energy, negative energy. So you can understand that there will be corridors of positive energy and corridors of negative energy. So these corridors are called as push bands and pull bands. So you can see that the emerging distribution of the electron is such that there is a very high amount of positive energy core, and there will be a lattice structure of negative energy particles, which are mutually repulsive, and they are attracted towards the core, but they are mutually repulsive. And then what happens is that this whole thing is absolutely rotating, and what happens is that there will be zones, very thin zones of positive energy and negative energy. That is, there will be active spatial expansion zones and active spatial contraction zones. Now, ideally, these push-pull bands will move outwards in extremely complex paths, spiral paths, depending on the movement or the rotation of the lattice structure, which means that these will be actually extrememly complicated paths, and some of them will be positive energy, some of them will of course, there is much more to the structure of the electron like this, but you can actually see that the structure of the spinor, which we had seen at that time, is actually not very far from the description of the electron, which is emerging out of dynamic general relativity. So dynamic general relativity, you can imagine that in the center there is huge amount of destruction happening, 10 to the power 10 to the 10